Maddox, I did too. I saw you too. I'm good. I have a little bit of cough, so I'm kind of eating a cough drop now. So, but I'm going to get you guys into some vocabulary review. All right, so we're going to play a little game here. So, ask you which of the Blooket games you want. Is it A, crypto, CRYPTO, or is it B, fishing, or is it C, cafe? And then I love that game where it's what is it? D is um, gold. I love that one. Bar stealing gold. Which of those do you guys like to play? Let's start a poll here, and I'll get this game going here. And where are you, game? Where are you? Vocabulary forces, vocabulary practice. Let's do some of that. What are the three forces, Newton's three forces? All right, looks like fishing is, oh, that's fun too. Fishing's really a lot of fun. Crypto, I like crypto too because I get to try and guess your passwords and stuff. So I'm going to jump in this one. Oh, well, looks like gold and crypto and fishing are neck and neck. I need to have, all right, it's going to be fishing frenzy. Okay, good job, guys. And then we have to give away those people that got into the exit quiz yesterday. I've got a giveaway for some more free, the science giveaway free assignments. So there we go. Let me give you the music here as well. Share this one with you all. Thank you guys for participating. I really do appreciate that for you guys. All this stuff because like even doing the exit quiz, excellent way to for me to see if I need to go over the math, which I do. I kind of thought I was going to do that, but again, see who knows and who doesn't know is something that works for me. Okay, so let me go and put this in the public chat here. Let me give you the link. All right. So you got that there already pretty quick, Janaya. All right, you guys are on top of things. So again, we'll be having a giveaway. I need another giveaway for a free assignment right after this. So we did the exit quiz yesterday. You're in that drawing, and I do appreciate that because it's like I said, the hardest part that people find for science, concepts kind of can be a stretch. The vocabulary for sure is hard. Yeah, because there's a lot of words that we've never used before. But doing some of the math, you get really frightened about it. I don't want you to be frightened. Hey, Isabella. Sure, not a problem, Isabella. Need something to wake up with. Okay, we got 5 people, 6 people. Jay is here. Jay is here. Where are you, Jay? Are you sure you're here? Yep, Jay is here. And Juan's here. Reese is here. Anybody else? Rainy for getting in there. You guys are so awesome. All right. Let's go. 7 out of 16. Skip this. You guys know how to play this. And dash. Well, it's going to go down from 60 degrees to 27. I think we're at 57 by tonight. So it's going to be a chilly one. 10 seconds. Maddox is in the lead. He's gonna, unless we swap. Can you swap? I like the swapping part. Dun 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 dun. Noah, things. Okay, you guys are really good at the vocabulary. Let's take a look at the spinner poll here. Okay, so let's do this. And let me upload something while I'm waiting here. So again, remember, you have to be present in order to win, right? So make sure that you are available or here. Where are you? 228. Where are you? I'm in week 5 again. That's not what I want to do. I want to be in week 6. 228, Newton's third law. We're on Newton's third law, guys. We're excited. We're 3 of 3 today. All right, so let's see who, you guys are an advisory. All right, so let's see who's the winner today. These are the people that did the exit quiz yesterday. All right. We had Anella, Rainey, and Caleb. Caleb has to say hello for them to get a prize of a free assignment. So if you want it, Caleb, you got to say hello to us. So hello that you're here. All right, I will spin the name again. I just wanted to see that you are here. I know your name is here, but I don't know if you are here. All right, give you 10 seconds. 10, 9, 8, 7. Got to just say, I'm here. I'm here. You know, it's like Horton hears the who, you know, I'm here. I'm here. I'm here. Oh, boy. Doesn't look like he's here. He might have walked away. Let's see who else is available here. These are the people that did the assignment in the exit quiz yesterday. I really appreciate you guys. Rainy! Oh, my gosh. Rainy's here. Woo-hoo. All right. Rainy. And he is here. All right. Okay. All right. So where are, oh, you're on the second page here. Thanks so much for doing those exit quizzes, guys. I know that some of them are not in your, what you want to do, but it really helps me to, where are we? The 28th. Okay. 28th free. All right. So I'll have to see it. Did you do both, both assignments for week 6 already, Rainey? Week assignment 1 and 2 for week 6. Okay, so just remember, it's week 7. All right. So tell me which one you want to do. If you want to wait till week 7, you just have to remind me. Okay. I trust you. All right. Thank you guys for doing the exit quiz. All right. So today what we're going to do is we're going to take a look at Newton's third law. All right. And this is not it. This is it right here. Okay. Nope, that's not it either. All right, where are you, my Newton's third law? Where are you, Newton's third law? Okay. Let's go back to recent here. Okay. Newton's third law. Okay. There he is, right there. He's right in front of my face. Okay. So in Newton's third law, the object is the understanding of the law. For every action, there's an opposite and equal reaction, knowing that an action reaction actually are different objects and they do not cancel each other out. Makes, you know, because we talk about, we'll be talking next week, it'll make more sense. But this week, we're just kind of giving you the basics here. All right. So understand the law that for every action, there's an equal and opposite reaction. Identify the action reaction forces, and we identify all the forces around us, right? So let me show you this. These are kind of cool images here. So I'm going to show you my screen here. All right. We're going to look at Professor Dave again today. So Professor Dave is going to follow us today, and we're going to do some questions. So get in the poll and get in the drawing for the free science assignments here. So let's do this. Okay, so I'm gonna get move on here. So here, every action is equal opposite reaction. So here is something from I keep thinking this is Bart Simpson, but that's not Bart Simpson. I can't think of the name of this show right now. Right? So we're going to look at Professor Dave, and he's going to talk for a few minutes about action-reaction pairs, and hopefully it'll make some sense to you. If not, we'll go over it a little bit more. And there's some poll questions shortly after this, okay? So let's do this real quick.
Hey, it's Professor Dave. Let's talk about Newton's third law.
You guys hear this okay?
Regarding the proportionality of force and acceleration, we are ready to round out the trio and look at Newton's third law of motion. This is most famously stated as follows. For every action, there is an equal and opposite reaction. While often quoted out of context for metaphorical purposes, in physics it means something specific and quantitative. It means that if two objects interact, the forces they impart on each other will be equal in magnitude and opposite in direction. Think of a car hitting a brick wall. The car imparts an action force on the wall from its motion, and the wall imparts a reaction force right back on the car, bringing it to a quick stop.
Two forces, action-reaction force, right? And there are on different objects. Now, we're going to be talking next week about drawing vectors, and we're going to be just doing the parts of the car, not the brick wall, but this is a good thing to think about here. So let's take a look at some of the questions we have for you. All right, so of these, this is a poll question here. Start a poll. Oh, I forgot to publish a poll. Let's do this one. All right, what does the third law state? Objects at rest will remain at rest. Objects in motion will remain in motion. For every action, there is an equal and opposite reaction. The force of gravity varies, with altitude. All right, so I got 8 out of 21. Thanks for participating, guys. Everything you do helps me out considerably. I really do appreciate you that you get in here and do these things for me. I know it help. You might be off and away, but I got 9 out of 21. So, and it's the letter C, right? Every action there is an equal and opposite reaction. So there are only 3 Newton's laws, and this is a vital one to remember. All right, so let's do this one. Newton's third law says the forces are equal in magnitude and the same direction, unequal in magnitude and opposite direction, equal in magnitude and opposite direction, or varying in magnitude and random direction. All right, so we got 6 people. 6 people. Okay, so 6 people, 7 people. So it is the equal in magnitude and opposite in direction. Let's talk with Professor Dave again. I love Professor Dave. He is my big bro. All right, so my younger bro, actually. So let's go here. I'm going to turn my screen off here. Get this in big scape here.
These vectors are equal in length and point in opposite directions. What this also means is that there can never be a single isolated force, as any force is an interaction. Forces must always exist in pairs. As you sit in your chair right now, the force of gravity is pulling you down towards the center of the Earth. But something called the normal force points straight up with the same magnitude, which is why you remain perfectly still. We will learn more about this force later. The third law can sometimes be confusing because it would seem to imply that no object could ever move, since any force accelerating an object must be paired with another in the opposite direction. For this reason, we must understand that when assessing the motion of an object, we consider only the forces acting upon that object, and not the forces that it applies on other objects. When hammering a nail into a piece of wood, the hammer imparts force onto the nail, and the nail imparts force onto the hammer. But the nail is driven into the wood because there is a net force acting upon the nail from the motion of the hammer. Likewise, the hammer has two forces operating upon it: the downward force from your arm and the upward force from the nail. That's why when you strike the nail, the hammer stops moving at roughly the location where the impact occurs. So if we are looking at the nail, we only consider the forces acting on the nail. If looking at the hammer, we only consider the forces acting on the hammer. These are different systems, and this is the context in which the third law is best understood. Let's look at another example. When a rock falls to the ground, the gravitational force from the Earth causes the object to accelerate towards the Earth, but it is also the case that the Earth is accelerating towards the rock. This must be true according to the third law. Of course, we don't notice this in everyday experience because the acceleration of each object is inversely proportional to its mass. The rock is very light, so the rock accelerates quickly. The Earth is very heavy, so Earth's acceleration is completely negligible. This may seem a bit abstract, but it is important to be able to rationalize forces in this way. So there
Kind of strange to think about that the Earth, as the rock goes down toward the Earth, that the gravity is pulling the rock down, and then the Earth is accelerating up. Amazing to think that those would be equal. The acceleration on those, because of the size of the masses, is what's different. So that is a strange thing about this. Cancel here. All right, so let's take a look at a couple more questions here. All right, which example of Newton's third law did he show that was for third law? Did a bird flying into the sky, a car hitting a brick wall, a boat sailing in calm waters, a balloon floating in the air? So if you remember, I think most of you saw the car, right? Most of you saw the car hitting the brick wall. So the forces were equal and opposite, and they were isolated, two different systems here. Okay, 7 people. Thank you very much. Great job, guys. Car hitting the wall. Here's why does a person sitting in the chair represent in the Newton's third law? Due to the force of the wind resistance, due to the force of magnetism, due to the normal force equal in magnitude to the gravity. So if you said that it was due to the, not that, it's due to the normal force in that particular one. Let's go back here. Let's publish this poll. What happened here? Oh, I went too fast. So it's due to the normal force equal in magnitude and gravity. So the normal force is the strangest force, the supporting force. I wish it was called the supporting force. Why it's called normal, I have no idea. All right, so let's take a look at Newton's third law. For every action, there's an equal and opposite reaction. The block's weight pushes on the ground pushes up, and they're equal and opposite, right? But they are two different systems. All right, so how Newton's third law works. All right, you push on the rock pushes back on you. The boy pushes on the wall, he exerts a force on the wall, known as the Newton's third law. At the same time, the wall pushes back on the boy, and that's the reaction force. The action force is the boy pushing on the wall. The reaction force is the wall pushing back on you. Now, if there's some reason that wall did not have enough reaction force, your arm would go through, right? So if you push on a wall and it doesn't push back, it can't push back with the same force, then your foot would go through, or your arm would go through. Same with the floor. All right. For every action, there's an equal and opposite reaction. Let me show you some more of these cool videos here. Let me do that. So I love these experiments here that they have. All right, let me show you this. We're running out of time. Oh no, it's already 9:30, Mr. Bill.
There you have it.
All right. All right, so let's escape here. Okay, so let me go next one here.
It's Professor Dave. Hey, it's
All right, let me go. Okay, brick, wall. So here is Bart. Okay, can kind of see Bart on a chair here, and the force of the rocket going off, and then the exertion of the opposite force in the opposite direction by the ground. So this guy did this before Bart Simpson did. So Bart Simpson is not the only one that's done this experiment. I love this guy. This guy is a great physics teacher in college, probably older than me. Yeah, you know, that was if you ever get into a physics class in college, the experiments are really great. Really great. I love them all. All right. So let me give you a couple more questions here. All right. So the force of the rocket and the force of the hot gas. So the rocket, the gas is pushing on the rocket's pushing on the gas. So look at what happens here. This is a really interesting one too. Do you see this? Force A and B are the equal. So depending on the mass, so this person's pushing back, and there are two people there. The mass was different. You can see that one pushes back. They're both equal, but because they're much more mass on the other two people on the right, it doesn't accelerate as much. But the forces are each equal. So action reaction pairs, action on the ground reaction on the right. Corgi proves the third law, right? All right, so let's do this one right here. Let's do a couple more questions here. Just make sure that we understand this. All right, so here we go. Oh, still have that cough wanting to go. All right, what is the action force? Is it the blue arrow, the red arrow? It's either the blue or the red arrow. Which one is it? Blue arrow, the red arrow? Gravity. Two more questions here. No action force. What? There is an action force. Action and reaction pairs, right? All right, got 6 people, 7 people. Most of you guys said the blue arrow, right? All right, blue arrow. All right, which has greater force, A, B, or C? This is trying to get you the idea behind Newton's third law. All right, I got most people saying, oh, not now. Okay, got most people saying, now look at the arrows. They are the same length, right? Same length. All right. They are both the same. Most of you guys said the same. They are the same. Action reaction pairs. All right, so let's see about this one. All right, so what is the ball pushes? Let's see, I can't get A or B on this one, can I? All right, so type response, start a poll. So A or B here. Left or right? L-E-F-T, L-E-F-T, or right, R-I-G-H-T, R-I-G-H-T. Which is it? All right, left or right? Start a poll. Left or right? So the ball pushes, the baseball pushes the glove leftward. The glove pushes the baseball which way? The opposite direction. Rightward. Right. You guys got it. Okay. All right. So we're done right here, ladies and gentlemen. Okay. We're gonna you have an exit quiz that'll so I get to pick on exit quizzes, bookets, and all those things for the daily giveaway. So you might want to make sure you do the exit quiz today. So let me stop right here and give you some instructions here. Okay, default, here we go. Okay, so I had 107 people, 117 people not do week 5 quiz yesterday. It was due on Monday, so I gave you a little bit extra time to try and get it done. So make sure you look at your old assignments, make sure you're caught up on, because we went over week 5 assignment 1 and 2 on Monday and Tuesday, right? So so make sure you're doing W5 assignment quiz. So this quiz on force types was due, and there's, like I said, there's 117 people that didn't do it out of 200. So, and again, that was due yesterday or Monday. So get that done. So get your grade up. Right. Also, there's an exit quiz on Newton's third law. So get that done. It's only open for a day, so get that in there, and you can get in the drawing for the tomorrow, because we're going to have, well, tomorrow is Thursday. So I'm going to do a blind drawing, and then I'll email things out. So, I may use the poll votes. I may use the exit quiz. I get to use a lot of different things where people participate, or even the booklet. All right, so I'm going to have open notes, or if you need some help on, oops, let's see, why did I get help up there? If you need some help on the problems, like force equals ma, so I'm opening the big blue button for that. So I don't have names of people, so if you could just pop on over, and I'll go over the exit quiz from yesterday and show you how to do those problems. That is, so I'll open that up for anybody that has a question about their grade, or they need some help with the math. Okay, so I'm going to stop right there, ladies and gentlemen.